This is a short video to show how to use the Sharp EL-W516X calculator to enter some data so that we can find the correlation coefficient and the A and the B that we need for the equation. First thing to do is to get the calculator into the correct mode. So you're pressing the mode button, and then we're choosing 1 for stat, and then we're choosing 1 again for line because this is linear data. Now we have to enter the X and Y coordinates of our points. I have 6 points here. The X's are in grams, the Y's are in centimeters, and I'm going to start entering them. So I put 10, and then I press the XY key, and then I put the Y coordinate, which is 20, and I press the data key. And it tells me data set equals 1, which means I have entered 1 point. I'm going to do that 5 more times. 11, XY, 22, data, 12, XY, 24, data, 11, XY, 25, data, 14, XY, 27, data, and finally 16, XY, 28, data. Data set equals 6. I have entered the X and Y coordinates for 6 points, so I have done that. Now I'm going to find the A, the B, and the R. The A, B, and R are blue. They're printed here above the open bracket, close bracket, and divided by keys. That means you're using the alpha button. So to get A, I'm doing alpha, open bracket, equals. And my A is equal to 9.5658. Rounded to the nearest 10,000th. Now I need the B. Alpha close bracket equals gets me my B, which is equal to 1.1974. Again, to the nearest 10,000th, which we do to keep as much accuracy as we can for our data for the answer to our question. But I also need the R. I may as well get it right now, so I do alpha divided by equals, and the R is 0.895. But then I like it rounded to the nearest hundredth, so I'm converting that into 0.90. Now it's time to answer the question using the equation. In most forms, we use y equals ax plus b, with the a as the slope and the b as the y-intercept. But when we're using the calculator in this way, instead we use y equals bx plus a. This is because the a and the b have been reversed in the chip in this calculator. So therefore my equation is y equals 1.1974 x plus 9.5658. I'm answering this question where we're plugging in an x of 13. So I replace the x with 13 in my equation, and then I simplify. (1.1974) times 13 plus 9.5658 equals, and I get an answer of 25.132. And that's a y coordinate, so it's going to have the unit centimeters. I have answered the question, but I need to use my correlation coefficient, the R value. And the way I'm using it is I look at my answer and I say, and I have confidence in this answer, because my R value is strong. Of course, that means I have qualified my correlation coefficient. And using the line from the table, I am able to say 0.90 is strong. I also say that it's positive, even though that might seem obvious. I make sure to say it. And I can tell it's positive by looking at the data. As the x coordinates get bigger, the y coordinates also get bigger. That implies a positive slope. And finally, I want to give the line from the table, which is 0.85 is less than or equal to the absolute value of R, which is less than 0.95. This simply means 0.90 falls in between those two numbers, and it justifies us in saying we have a strong correlation. That's how to use the Sharp EL-W516X calculator to enter some data and answer a question about correlation.